Let's discuss the link between the binomial and the Poisson distribution. The binomial distribution with parameters n and p is approximately equivalent in distribution to Poisson when mu equals n times p. The symbol mu is supposed to go right here. This is true assuming that n is large, p is small, and n times p, the average, is less than 7. For example, the probability that a cow has trig is 1%. A random selection of 20 cows, each from a different herd, are tested for trig. Let x equal the number of these cows that test positive for trig. Does this satisfy the binomial criteria? If so, use the correct notation to write the distribution of x. Let's check our conditions. We know that x is the number of cows that test positive. So in our setting, x would be binomial, remember bi meaning two outcomes. Well, either the cow tests positive or negative. That's two outcomes. The next condition is that you need a fixed sample size. It says 20 cows from each herd were selected at random. So there is a fixed sample size. Our next condition is that we need a constant probability of success. Here it says the probability the cow tests positive that a cow has trig is 1%. And remember, we were counting x equal the number of cows that test positive. So we know the probability of being positive is 1%. So we can say there is a constant probability of success. The fourth condition that you need to satisfy the binomial criteria is independence. Now I don't have enough room on this page to write down why they're independent, but on the test you'll have to justify why these cows are independent. Each cow is from a different herd and the cows were selected at random. So the outcome of one cow is not going to affect the outcome for another cow. Therefore, they're independent. Use Poisson approximation to the binomial distribution to find the probability that at most one cow tests positive for trig. Recall that when we worked out the probability for this example with the binomial distribution, the answer came out to exactly 0.817. We know that x is binomially distributed with a sample size of 20 and a constant probability of success of 0.01. According to theory, x should also satisfy a Poisson distribution with a mean equal to 20n times 0.01 p. If you work this out, this gives back 0.2. n times p is less than 7, so this is an accurate statement to make. Now the question asks us to find the probability that at most one cow tests positive. Let's think of this on a number line. We know that 0 cows could test positive, 1 cow could, 2 cows could, all the way up to all 20 cows could test positive. If at most one cow tests positive, we're looking for the probability that x could be 0 or 1. To work this out, we'll find the probability that x is less than or equal to 1. And this is the probability that x equals 0 plus the probability that x equals 1. We're now going to plug this into the Poisson probability formula. Remember, the probability under the Poisson distribution that x equals a number is mu to the x, e to the minus mu, over x factorial. Here we know that mu is 0.2. So all we have to do from here is plug in the number 0 for x and then plug in the number 1 for x. So now that the values are plugged in, we can go through and simplify. Anything to the 0 power is 1, so this goes away. 0 factorial is 1, so this goes away. 1 factorial is 1, so this goes away. And 0.2 to the 1 power is just the same as 0.2. So in the end, this simplifies to e to the negative 0.2 plus 0.2 e to the negative 0.2. When you type this into the calculator, you'll get about 0.82 plus about 0.16. So in the end, the final answer is about 0.98. If you compare this with the approximation of 0.187, They are pretty far off, but remember, this is an approximate answer. This one is an exact answer, so they're going to have to be slightly different. Use Poisson approximation to the binomial to find the probability at least 2 cows test positive for trig. Recall that when we worked out the probability for this example with the binomial distribution, the exact answer was 0.183. Remember, x has a binomial distribution, n equals 20, p is 0.01, and we said that x also has a Poisson distribution with a mean mu equal to 20 times 0.01 n times p, and that came out to 0.2. We now want to find the probability that at least 2 cows test positive. So that's the probability of equaling 2 cows or having more than 2 cows. Well, let's put this on the number line. We could have 0 cows testing positive up to all 20 testing positive. If we want to find the probability of at least 2, that means we want to find the probability of 2, 3, 4, 5, all the way up to 20 cows testing positive. Now remember, the entire sample space adds up to 1 or 100%. So what we could do is 1 minus the probability of equaling 0 and 1. And the idea is that if you take 1 and subtract out the 0, subtract out the 1, it should leave over the 2 through 20 that we were looking for. So to work out this problem, we're actually going to find 1 minus the probability that x is less than or equal to 1. Now this is what we found in the previous example. This is 1 minus 0.98 or 0.02.